Hello, everyone. Could you please lower your voice a bit? So definitely come to the front. We still have like 10 or 15 seats if you want to get seated. It's much colder here in the front, so everyone should be rushing in the front right now. I hope you had like a nice meal. Many people have been asking me if I have been pulling this out of my own pocket. I have not been pulling this out of my own pocket. As I said earlier, Github supported us a bit, but like the biggest sponsor we had this time was JSConf. So give a hand to the JSConf conference, I guess. They're providing beer. I hope you had like a great time mingling. We're going to continue with the schedule. We have 2 talks left. One will be short, like 10 minutes, 5 or 10 minutes, and then we end with like a 20-minute talk, 15-20-minute talk. It's much colder here, so I'm pleased with that. Without further ado, Sveitfloki from Github is going to introduce us to the world of scraping. So give him a good hand.
Right. Hello everyone, I'm Sveit. Nice to see you all here, and I'm going to talk about a little personal project I made over a weekend in April this year. Okay, so there are all kinds of data publicly out there, often scattered around in many places, perhaps in separate, unnecessarily many formats as well, just lying around, waiting for someone to come around and gather it. A Friday evening in April, I was facing a problem. I realized that I had no solid overview over gas station locations in my vicinity. Mostly I just knew the locations of those stations I had used before or happened to know about. I was aware of some existing price comparison sites, for example gsmbenzin.is, which exposed names, addresses, but that wasn't really helping me to get a feel of nearby station locations. I felt this information needed to be available somewhere in one place. It wasn't. So I decided to change that. So, the task. I needed to gather 2 things. 1, locations of petrol stations, preferably in the form of geo-coordinates, which would be easy to add on a map of some kind. And 2, petrol prices mappable to each station. I started by going through the Icelandic oil companies, checking their websites and what information they were exposing. All of them exposed a list of their operating stations, their addresses, and either global or individual petrol price for each of its gas stations. Following, it was a rather easy task to extract a list of stations with geo-coordinates included for most companies using plain scripts. But for some companies, the exact coordinates weren't exposed, and I had to resort to some hideous manual labor to check semi-precise coordinates for each station. Following this, I gave it some thought if I could possibly make some automatic new stations detection. But because the new stations are not frequently built, and even if I would make some automatic detector for this, it would most likely break more often than new stations are built. So I ended up just using hard-coded list of the stations that I had gathered and acknowledged the fact that I would need to manually add new stations as they would be built. Writing gas price scraper for each company website and map the prices to every station turned out to be remarkably simple as well. There were some things needed to keep in mind though. Some companies provide separate list prices and discount prices, where list price is the amount you pay if you don't have any company card, gas key, or any discount contract, and discount prices if you do. I had actually seen this being messed up on like gsmbenzin.is, where they were showing list prices for some but discount prices for others, and that was terrible. Sorry. It's been really trending for Icelandic oil companies for many years now to play these discount games. Yet some have started to seize this game with subsidiary companies, for example Skeljungur with Orkan X and now N8 with Dylan. After getting all the gas station locations and making scrapers to fetch prices, I made a list of objects such as this one. A list of 253 objects like this for every station in Iceland. Great success. Yet, at this point, I felt there was some missing potential here. Sure, knowing current prices was pretty good, but as looking up the current price data had proved to be this easy to do, why not also log gas price changes over time? This would require some gas price logging system. Or would it? I realized that I could simply use Git to monitor the gas price changes. Git is a version control system for text files after all. And all the data and scripts I was using were just that, a bunch of text files. I'd like to mention though that using Git to monitor changes may not be ideal approach for every dataset out there. I'd say it heavily depends on the size of the data set and how frequent it is modified. But for this case, using Git to log price changes sounded like an excellent idea. A human-readable JSON file with all the gas stations, location, and gas prices was just over 3,000 lines. Assuming gas price changes would occur maybe once or twice per week for each company, I safely assumed Git would handle this task without immediately growing out of hand. Another reason to use Git for this, it made it straightforward to share the data with others. I would only need to set up a public GitHub repository, for example. And with that, anyone interested in the data could simply clone it or access the current master for current price data. I was a bit worried though, that if this project would catch on by any chance, which it maybe hasn't at this point, and requests to the repository would increase dramatically, Github might not like that they were being used as an endpoint of some kind for data. So, I attempted to ease those worries by creating a pull request on apis.is, which added an endpoint to my GitHub endpoint. The cache time on apis.is is configurable. I simply set it to 15 minutes, as the price lookups are run via cron job now every 15 minutes, which auto-commits price changes to the repository if there are any. This way, the repository would at most get a single hit every 15 minutes or so. Yeah, or so. Apis.is is a wonderful tool which I believe many of you here have heard about and even used for personal, school, or work-related projects. If anyone here has not heard about it, check it out, it's awesome. It has many nice things that you can look at regarding fetching information with JavaScript and throwing it forward. I must admit though that my project actually didn't use JavaScript, it was written in Python, but that was simply because I had more experience of scraping things in Python than JavaScript at the time. So, here is the setup of what I've started to call Gaza. It consists of a single Raspberry Pi with the sole purpose of checking for price changes every 15 minutes, and in case there are any, auto-push them to the public Git repository where anyone interested in price changes over time can access that. For those interested in only the current gas prices, the apis.is endpoint exposes just that with minimal effect to the Github repo itself. In addition to this, my faithful red Raspberry Pi notifies me on my personal Slack channel, both when new prices appear and when the scraper fails to run. Well, this is a scraper after all, it's bound to break every now and then. Poor thing. Now, I made some point or conclusions following this project. One point is inexpensive. Data collection setup like this can be set up and kept running with little to no cost, other than occasional spending time on maintaining scrapers when something breaks and keeping a Raspberry Pi or something else plugged in somewhere. Potential value. I believe projects like this could hold great value, perhaps even more so when the results are exposed in this manner, where anyone can dig into the data for themselves. Git is good, and we could use it a lot more, I think, for many other things than version control for programming projects. Just imagine, for example, if our respectful Alþingi would start version controlling our constitutions and other regulations in an Icelandic public Git repository. I'd like to think it would be amazing. And last, not least, time series data sets can be interesting. In cases where data changes frequently changes over time, it is often interesting to log most of all modifications with a timestamp and to create a time series dataset. Time series datasets are interesting to view and analyze. Often it is more interesting to see how the data has changed over a time frame than looking at the most recent data. Thank you for the time. Here are some fancy graphs and maps. Woo! Questions, Rosalie?
You mentioned that you had to manually input the locations of the gas stations.
Yeah.
Did you consider cross-referencing the address with Google Maps or something?
At the time, yeah, the question was I resorted to manual labor for getting some geo-coordinates for some stations. Damn you, Olis. And he asked if I had thought of cross-referencing addresses in Google Maps or something to like get a geo-coordinate. At that time, no, I didn't think of that. But if I would, then I might have like checked it just to be sure, regardless. But yeah, that was something I should have done at that time. But as the stations weren't that many, I resorted to manual labor because, yeah, it is what it is.
How did you do the scraping? Did you use a helper library like Google Soup, or did you just DOM walk or do regexes?
So the question is, what libraries did I use to scrape things? I'm using Python, and I mostly used just the module called requests, and then a library called XML, which parses XML and HTML. And all this code is available publicly on GitHub if anyone's interested. It's over here, github.com/gasvaktin/gasvaktin.
Thank you for an interesting talk. I want to encourage everyone to reach out to us to be able to speak, because we have never said no to a speaker, I believe. There are just so damn few of you that want to speak here, even though if you get a lot of attention, and it's a great venue to start speaking, because, I mean, if you're just showing a pet project like Sveinn was doing, I mean, don't be shy, like the talk we were discussing before. You're not a fraud, even though you don't write the best scraper code in the world. I mean, people can use this data and do a lot of great stuff with it. So thanks for your contribution to us. Like, we can all pull gas prices now. Give them a good hand. Another thing, like he mentioned apis.is, not a shameless plug, but it's a great place that you can look at stuff, and if you have something in mind that is missing, definitely add it. It's super easy. Like the guys in the front here have been submitting a bunch of pull requests for the past few weeks, and we always welcome more people to our code base. It's getting 3 years old now, so it needs a lot of love, but it's a great starting point for people that want to just expose basic data. And one point on that, just after Sveinn published his dataset, a guy named Hannes picked it up. Just a random guy who works at some tourist company. I don't remember. Someone, I don't know, some tourist company here in Iceland. Trip Creator. Trip Creator. It's like a 30 people company here in Iceland, and he immediately picked it up and built this map that Sveinn showed you in the end. So immediately after he published his dataset, everyone could use it, and Hannes built it for his own convenience, and he started blogging about it, and a lot of people came to his website to check gas prices and stuff like that. So it's really cool that we can like share data in this way. Yeah, without further ado, our final talk is here. One more thing, maybe you can plug it. We're probably gonna go to like a pub or a bar after this event, so if you want to join us, definitely hang on for a bit after this event. We have plenty of beer, so definitely finish that one, so I don't have to carry it home with me or something. I don't know. I will find a way to destroy it somehow.
Doris!
Yeah, but other than that, Arnar from Github is going to give us an interesting talk.
Woo!
Hello, my name is Arnar. I work at Github as a full stack engineer. I have this talk putting the pants on JavaScript, which is a really ambiguous name, but it's basically how we created a monorepo for our webs. What did you do?
Plugged in HTML.
Oh, okay.
No, that's not gonna work. Okay, just unplug it.
Ég skil. Tölvunni líkar ekki að vera þetta.
Nei. aftengdu það bara HTML ykkur en að hægra megin?
Já, við það. All right. So yeah, how we created a monorepo for our webs at Github. So the pain points of having like multiple projects for every project, or multiple repositories for every project that you have, is that every project is sort of a representation of best practices when it was first created. And that doesn't get updated a lot. So you have like, we, for example, had 5 projects, and we had a different setup phase for every repository that you cloned. Our deployments changed. First we had scripts, then we had like CI, which was a GitHub plugin for Jenkins. Then we had Jenkins files with auto deployment, and this doesn't get changed in the older repos. It's just better in the new things. And what this does is that code rots in old projects, and no one wants to touch them because no one knows how they work anymore. Or even the developer who first did it, he doesn't work here anymore, so literally no one knows how it works anymore. And another thing is like, you do all of this duplicate code. You have a boilerplate for your server, and it's always the same, but you have to duplicate it to all the places that you're doing a new web. And then you update how service discovery works, and it doesn't get updated because no one does. And then the worst thing about us all is updating dependencies. Our first React project was built in 2014, and since then there have been 26 releases of React. And no one ever thought about updating the editor because no one was working on it. So we wanted to change this because we don't like this. Like going back to our web client now, that's Github.com, no one actually wants to work on that project because it's not the new thing that we're using today, and it's not as up to date. Late last year or early this year, I can't remember, we started doing a monorepo for our server code. So we decided to use like Scala and Java for most of our things, and there was this tool called Pants that does, it's like a build framework or build tool that helps you put all of your code into one repository, and then you have one command to run everything. So if you want to work on the feed, we just do pants run feed, and it runs locally. And the same for comments or games or whatever. All of our server code is just in one place, and it's the same command to run everything. And you only need to set up one repo. So this gives you the same structure for every project. So if you're going to work on, I'm going to work on adding, you can now post pictures to the comments. So I have to edit the comment service and the attachment service and maybe the web or something. And now all of this code is in the same place. So I don't have to have synchronized PRs and synchronized deployments and everything synchronized. It's just all in one place. So, and also what this gives us is now we run a lot of our things in Scala, and we run Finnegal. And if Finnegal updates, we just bump that one dependency in this one project, or this one repository, and it will automatically deploy 90% of Github, and we don't even have to touch it. We just merge the pull request and everything goes out. So it gives us like a single setup, and code sharing is automatic because now if we have, for example, a player, which is a core element to our infrastructure, if I'm now going to call the player service and get a response, we have all, like in Scala, you have type safety, but now I can use the same model that the player service is exposing. I can use that in my other service that's calling the player service. So I don't have to duplicate my player object all over the place. And this was like our motivation to do the same thing for the web, because We have a full stack team, so we work on both server and web code. And we hated that the server code was nicer to work on. We wanted the same thing. So we wanted to go from this over to this. And how we did that was, we thought about using pants, because we used it in the server monorepo. But the Node construct module for pants isn't really good. And we weren't willing to sacrifice any of the developer experience we had already. So we had like a developer experience with Webpack and Babel and Flow and ESLint and all of these things. And we had hot reloading, and we were not willing to sacrifice any of these. And NPM is a great package manager, and we were definitely not willing to sacrifice that. And how Pants does it is, you have to define your dependencies in their ecosystem, and then they install it for you. And we didn't want to go there. So the first thing we did was we were inspired by Pants, so we created a dependencies.js file, which looks like this. This is the dependencies.js for our server in Jarvis. And as you can see, it depends on Express and Lodash and a lot of other stuff. And then it depends on our shared code, which is down here. So it depends on our shared API and a shared server. So now we have all of this boilerplate code, and it's defined in a shared folder, so you can just include it in your project. The next thing we did was we created JavaScript scripts for task running. So we now have 4 projects in this monorepo of ours, and this is what the scripts part of package.json looks like. We only do like dev or test or whatever, and then we give it the --s and say the name of the service. So our task runner he accepts a shell command, which is a template string, and then he reads this parameter .s and exchanges the name of the service that he wants to run, for example, tests for. And then the last thing we did was we created CI scripts, because we don't want, like if I change something in the Jarvis project, I don't want all of our services to deploy, because it's unnecessary and it takes a lot of time to deploy everything. So we created CI scripts, and you can ignore the shell scripts, they're just because Jenkins doesn't know how to run Node. But we have a script here called change targets, and that's sort of the heart of our monorepo here. Change targets does sort of 4 things. It starts off by finding all dependencies.js files in our repository. It creates a full map of every dependency that is in this repository. So we can look up, if Jarvis has changed, we can look up all the things that Jarvis depends on and see if something there has been updated. For example, a package update in NPM. Then it takes the git diff of your branch and the latest master and checks all the files that have changed. The first thing it does is we have a folder structure, so it's like our services are source and then some name of a service or shared, and then we have like the source code for everything. And first off, we just check, does, for example, source Jarvis, is that a file that has changed somewhere? If so, then this service has changed, and we need to keep that in a list of things that have changed. Next thing it does is it checks package.json. Did that change? And if it did change, it checks for every development dependency and sees if any of those have changed. Like, have we bumped the target? If that happens, we always roll everything, because we use Babel and Flow and ESLint and stuff like that. And if a development dependency updates, it could potentially break our tests or our build or something like that. So we always deploy or test or run everything when a development dependency updates. Otherwise, we check if it was a dependency, we check what services depend on this and like update those. So if we, for example, update React Date Picker, there's only one service that depends on it, so the others won't get touched. And lastly, we check did any shared code change, because as you can see here, Jarvis depends on our shared server. So if we update our boilerplate for the server, we want to deploy all services that depend on that one. So it's that simple. You only have to like read your git diff and check for these things. It's not more than that. So the benefits that we get from this is that now we have, throughout all of our web projects, consistent code style. Because we have only, in our shared code, we have ESLint, StyleLint, and flow configs, and Babel configs, and Webpack configs. And these are all shared through all services. So they all run exactly the same. We use Greenkeeper, which is a service that provides you with an automatic pull request as soon as a npm dependency that you use is updated. So if React updates from 15.2 to 15.2.1, we get a pull request automatically. So this keeps all of our projects up to date by default. Even though we're not working on them, they're always up to date. So Kodson, actually, I have to give him huge kudos because he took the 2014 editor and put it in there, and now it's actually up to date. And if we're going to work on it, it's not the most sophisticated stack, but at least it's up to date and we know how the API works. A great thing about this is code is shareable by default. You're writing it in the same repository as everything else. So if you want to share it in another project, it's there. You can just use it. You just import it. And like bootstrapping a new service, if we want to do yet another web, it's as simple as you just create a new folder and start writing code. You probably want to copy paste some of the like React setup and stuff like that, but it's as soon as you have a new folder, you have a new service, and it gets deployed automatically. We don't have to do anything about it. And also, like all boilerplate code, like I said, we have server, Redux setup, React setup, Webpack, Babel. All of this is shared in a single place. So if you update any of this, it gets deployed to all services automatically. And like the biggest plus side for rapid growing companies to try this out is it's super easy to onboard new people. You have one project, they only have to clone one project to set that up, and in our case that's just clone it and run npm install and you're ready to go. So as soon as you try working on one of your webs, he knows all of the others because consistent code style. It's everything is the same. And your deployments are the same, and like your pull request will be the same, and it just works. So yeah, that's it for me. Any questions? Yes?
Do you share components throughout the code base, or is it just like services stuff?
Question was, do we share components? Yes, we do that. So we actually tried out the other day. He created a topic search picker, so you could like search for a topic and it would be injected for an internal tool. And what he did there was pretty cool. He created a shareable module, which was the topic picker, and he created a reducer and actions and API and a component. So you only have to import this one thing and put it into your reducer, like root reducer, and then you're ready to go with a topic picker, and it just works. You don't have to do anything else. So yeah, we definitely share components. Yes?
The npm auto updater didn't cause any errors.
The Greenkeeper.
Yeah.
No, we have a. Oh yeah, sorry. Does Greenkeeper cause any errors? We have a pretty good test suite, so we haven't had. Oh yes, we actually had the other day, but that was our fault. We have a good test suite, so we haven't had any issues with it yet, except for this one thing where we were using an amplitude library, and we thought, oh, okay, this is fine, but let's use it in the client. And then they updated to 3.0, and we're asking for built-in promise support, and then we found out there was a node library, not a browser library. So we reverted that, but that's the only problem we had. All right, if you have any questions or something, just come and talk to me. I'm willing to share code if anyone's interested. It's pretty heavy, so I didn't want to include it in the slides. Otherwise, thanks.
So that will conclude our final schedule. Thank you everyone for coming. We will be staying here for maybe 15 minutes, so grab a beer, mingle a bit, and then we will probably move on to another venue if a lot of us are willing to. So thank you all for coming. Stay tuned for JSConf. Check out all the meetups that we have. if you want, you can buy a ticket to the parties, and we're looking for volunteers. So cheers.